Okay, well, MasterMinds, material selection mechanism. I'm Hernando Garcia, Juan Rocha, and Magdi Mohamed. Okay, basically a brief introduction. Vinyl, we're doing the project for Vinyl Corp, which is one of the largest extruding manufacturers here in the US. They go from designing corner beads, control joints, interior insulation finishes for exterior and interior. Problem statement. We have to design a material selection mechanism in order to optimize a current undergoing recycling process that the company is using right now. We have to categorize, as you see here, the pieces and sort it by size and even the weight. Some of the challenges we have now, there's a lot of material waste here. They cannot use it due to the contamination with the ground impurities. And all these boxes that you see here are the material that are taken by hand or physical labor there. We have to optimize that process right now. Some of the objectives, if you can see a little video that we posted there. See all the scraps coming in from the knockouts from the actual bead going through a punching die. All that waste there needs to be reduced. As you see, reduce the physical labor, sort and transfer the material for recycling, maximize the walking space, because now all the there are many boxes in the mills obstructing the walking space of the operators.
Our motivation for a project is basically to design a mechanism that is safe, reliable, and is user-friendly. We want to improve the process of recycling at this point. We want to gain professional experience by interacting with engineers and customers. And we want to introduce innovative prototype for other industries. Our proposed design consists mainly of the collecting station, where the pellets are going to go into the ducts, and the sorting station consisting of a wide selector valve and a rotating filtering system. Our major components consist of air compressor, air conveyor, a rotating drum filter, like I said, the Y valve, and a pressure regulator. This is how the air conveyor is going to work. So basically ramps air through point A, creating difference in pressure, so all the material can go from point C through point D. This is how the Y valve is going to work. It has to be automatic, and so basically the user is just going to, with the flip of the switch, be able to direct the material whether to one side or the opposite side.
Our cost estimation is the labor cost and component cost. For the labor cost, we have 195 hours, and for the component cost, we have 1130. And if we count $35 per hour for the labor, our total cost be around $8,000. The current system that are working in around the world right now, we can see that for the metal and for the paper shredder, that is existing in Europe and Asia. And there is also the existing design right now with the vacuum material transformation and the auger system to transfer the material. We believe that by using our project, we can reduce our world population to select and to recycle processing. And the two industries, major industry that we can work on is the food industry and the recycling industry.
Well, to basically conclude, our goals are to reduce the material contamination, reduce the energy usage, improve the material transportation that they currently use, perform a good product categorization, and globalized prototype. That's our presentation.
Okay.
So quick questions, I guess. How many different things are you trying to sort? I know we talked about this, but
I mean, we're trying to sort, the material has to be categorized for exterior and interior. They're two different types, they have different properties.
Right.
And further, like at the end of the process, we have to categorize by size. The large pellets that need to be regrinded, and the small pellets can be stored for future use to go to the extruder back again. It's just the big parts that will need to be separated to go to the grinding and then to the melting, go to the extruder.
Right. So with the filter system, you have, I guess, a different porosity within the filter to filter out the larger ones.
Correct. It'll be like, we're thinking now like a rotating drum with a mesh inside, a cylindrical mesh, that will allow the small particles to fall And we're using gravity, of course, it's coming from the top.
Right, right. So you
Right.
suck it up with the vacuum system,
Mhm.
you select interior, exterior really quickly,
Correct.
and then you send it down this filtration system. That rotates, right?
Correct.
So you have a motor to rotate that, or how are you going to rotate
Yeah,
it?
it's gonna be a motor and a fan to rotate that drum, the outer cylinder,
Okay.
solid cylinder, right?
Uh-huh,
So the smoke particles will fall
uh-huh.
and just continue rolling, and then from the
The
mesh.
big ones
the
will
big
go
one
all the way
yeah.
through?
Yeah.
Yeah. Okay.
That's the last part of the separation process.
And we try to incorporate those big parts to go straight into the grinder, like not go to a container, so the operators then have to move, which is gonna be the same thing. It's
Right,
just
right. So
connecting
go
into the
right
grinder.
in, so the small ones will go into one container, the big ones will go into another container,
Correct.
right? And then you'll use whatever.
For the prototype purposes, we wanna create up to that stage.
Uh-huh.
If the company wants to incorporate our prototype in their facility, they're gonna have to use some kind of another system because it's a pretty
So
large
maybe next semester
facility.
somebody will design that,
Exactly.
right?
So at that point, you can use augers
Uh-huh.
or even another vacuum system to take it to the more
Yeah.
to more
Correct.
distance.
In a prototype, just by using, the air conveyor to push it, it will give us power, I guess, push power to transport it to the filter, right?
So you guys know how much pressure you need to lift all of
I
the
mean,
specific
we
particles?
did
So
a- I did
smaller
a-
ones may be tougher, right?
Yeah, I did a test with a mechanic that worked there,
Okay.
and we use a conveyor of 80 psi, right? And that was
Uh-huh.
able to push the material up 13 feet above the.
So
the
all
shooters.
particle sizes, whatever was
Yeah,
moving,
every
you cleared
from
out
the
the whole
smallest
bit?
one to the
Okay.
largest one.
The air conveyor is ready for to work at 80 psi
Okay.
and push the material up.
So, and you did it at 60, right? So you've got some
Yeah.
room above that to
Yeah,
play.
we got some room to work with.
Okay.
I mean, it just depends on how much power you really want, because they are.
Yeah,
100,
right. You don't want this
150.
thing blowing.
Correct.
You know, blowing.
You just need to
Yeah,
transport
right.
it to, I mean,
Right.
they don't weigh a lot, those pellets.
Yeah. Mhm. But it's just about getting the right suction power to get it all.
Correct.
right.
Mhm.
Right.
I mean, I selected like the right hoses, we didn't mention there too, because those pellets really scratch.
Mhm.
So we need like the appropriate hoses for that, and
So I got one other question. Are they paying you $35 an hour to do this, each one of you guys?
well, it was an estimate.
That was estimating our working time. Of course, this is.
Yeah.
But basically, we're going to be spending materials and
Yeah.
the different components that we need to buy. For
Yeah,
that.
some of
And
the
so
materials,
they'll purchase those, or you guys have to do it?
we have to purchase some,
Uh-huh.
I guess for our own testing purposes, but if once
The
we
final
decide,
design you have. Okay.
they kind of
Sponsor us.
sponsor us
Gotcha.
for those.
Right.
Most of our expenses right now in our cost analysis is based on man working times, which is
Yeah.
it's a theoretical value.
Right. But again, we always want to make sure that you can complete the project based on costs.
Correct.
Yeah, yes, that's